I have a question for you guys. What is the most annoying and repetitive task that always takes an incredible amount of time when working on Proxmox? For me, it's the installation and configuration of new virtual machines. But today I want to show you how to simplify that whole process and how you can create new virtual machines on Proxmox in just a few seconds. And this won't be just a base installation. We will use a bunch of free and open source tools and techniques to create our own Linux server images that you can build based on your favorite Linux distributions, and you can apply users, SSH keys, and IP address configurations, or even provide them with custom shell scripts and software packages. So that when you need a fresh new virtual machine with Ubuntu and Docker installed, for example, you can just create it from a Proxmox template and boot this up in just a few seconds. This is so cool, and I hope it will save you a lot of time when you often create new virtual machines or to test and try out new things on Proxmox. So let's start and let's create our own custom virtual machine templates. Today's video might be pretty complex, so it could become a longer video. I've worked so many hours to get this working on my end, and special thanks go out to Spider on our Discord, who always helped me with this project and provided me his own templates, so thank you so much. Okay, let's get started with the first part that we need for this project, which is called Packer. And Packer is a free and open source tool developed by Hashicorp, and it is used to build custom machine images. So when you need a new Linux or Windows server, you can just use Packer to create pre-built images for any platform you need. For example, you can build images for cloud providers like Microsoft Azure, Amazon's AWS, DigitalOcean, or hypervisors like VMware, VirtualBox, and also Proxmox. It is a CLI tool that automatically creates these images from a template file. So you can, for example, create custom images with installed applications or user accounts, pre-configure authentication settings like SSH keys or SSL certificates, so everything that you or your organization needs to be present in that machine image. And this is pretty useful if you want to automate the deployment of resources, like using it for development, staging, or production environments on multiple platforms, or you want to quickly create demo appliances whenever you need them. You can install Packer on nearly all operating systems, like on macOS, Windows, Linux, and so on. I've personally installed this through the Windows Package Manager Chocolatey, and then it's also available in your terminal. What makes Packer so powerful is that you can integrate it in many different systems because it has tons of plugins and extensions. These plugins are mostly builders, so these are the components that are responsible for creating these machines and generating the images on the platforms, but you can also integrate it with provisioners like Ansible, Chef, or Puppet. I think it's always great what Hashicorp is building, by the way. They have so many cool DevOps and automation tools like Terraform and Vagrant, and now Packer has become one of my recent favorites. And now let's take a closer look at the Proxmox integration that's available in Packer and how we're going to use it in this video. And in the documentation you can see that it has two different builders available, so the Proxmox clone builder and the Proxmox ISO builder. We will use the Proxmox ISO builder for this tutorial because this can create new VM templates in Proxmox. And if you haven't worked with VM templates in Proxmox before, so this is a pre-configured system image that you can use to deploy new virtual machines. So on my Proxmox server you can see I have a few different virtual machines running, but there are also some items with a different icon. And these are VM templates that I have created. For example, when I need a new Ubuntu server that is already installed, I can just use the Ubuntu server focal template that I've built and just clone it to create a new virtual machine. Or maybe I need an Ubuntu server that already has Docker installed, so then I can just clone the second template. Cloning these images doesn't take long, and these virtual machines will be up and running in just a few seconds because they are already installed with an operating system, configured with settings, or installed with any additional applications. And that's extremely useful when you often need to create new virtual machines. You can also do this manually and create VM templates from any running virtual machine that you have installed yourself. But why do this manually if we have Packer? So that's what Packer will do for us on Proxmox. Packer will connect to our Proxmox server, create a new virtual machine, do the installation fully automatic, and run any scripts or configuration we need. And when it's finished, it converts this virtual machine into a VM template. And then we can use this template on Proxmox to clone a new virtual machine from it that always has the exact same configuration. Now that alone is awesome, but what if you'd like to create multiple virtual machines from your template that should have different IP addresses or different configurations? Or maybe you also want to share this image with your team, but you don't want your username or credentials to be included here. So that's why we are using another great functionality of VM templates in Proxmox, which is called Cloud-Init. Cloud-Init is the industry standard multi-distribution method for cross-platform cloud instance initialization. Does it make sense to you? No? Let me explain this in simple words. So whenever you need a new instance from a pre-installed image file, like a new virtual or cloud machine, you usually want to deploy it with different configuration settings. So you probably have seen this on public cloud providers before. So when you create a new instance, like a Linux server, for example, you don't need to install these systems because they are using pre-installed images, but you can still inject configuration settings during the setup, like a new hostname or a new user account or any password or SSH keys. And this is what you can do with Cloud-Init. So when a new Linux machine is deployed from an image, it looks for an existing Cloud-Init configuration and applies it to the system. And because it's an industry standard, it's supported by all major Linux distributions like Debian, Ubuntu, Red Hat, Fedora, and also FreeBSD and a few other ones. Most public cloud providers use it to deploy their machine images with configuration settings, and it's also used in private cloud environments like KVM or VMware. And Proxmox also supports Cloud-Init. On their documentation page you can see how that works and how you need to prepare virtual machines with the Cloud-Init package. And once you have a new virtual machine created that's prepared correctly, in the Proxmox Cloud-Init section you can add a username, a password, DNS settings, an SSH key, and IP configurations for these virtual machines. And when you boot this virtual machine, the Cloud-Init package inside this VM will apply the new settings to the system. This is something Packer can also do for us, so it can create a custom VM image that is prepared to work with Proxmox Cloud-Init integration. I know this is a lot of stuff, so once I heard about it, I was completely confused. And yeah, it might seem overwhelming in the first place, but trust me, once you see how it works, it will totally make sense to you. And of course, I will walk you through all of the necessary steps that you need for building this yourself. But first I want to say a few words about today's sponsor of the video, Teleport. Because with Teleport you can protect your remote resources like SSH Linux servers, Kubernetes, databases, or web applications with two-factor authentication and an audit logging. Teleport is entirely open source and free to use in the community edition, and suppose you want to use it in your company environment and secure your development or operations teams, in that case Teleport also offers an enterprise version with additional 24/7 support and single sign-on. It's a great application, so just download and try it out. You will find a link to their website in the description of this video down below. Okay, so I hope this wasn't a too long introduction for you, but I think it's always good to have a high-level overview of what we're doing before diving a bit deeper into the actual example. So let's now do this and start with a Packer template that I have created. And by the way, if you'd like to take a look at these templates and examples, I hope you already know my Git repositories, but in case you don't, you will find them on my personal GitHub page. So in the boilerplates repository, you will find templates for various tools and projects that I'm using in my home lab, such as Ansible, Docker, Kubernetes, and now also Packer. And here I've created some templates which are pretty similar to what we're using in this tutorial. These Packer templates consist of a bunch of different files. So first we have the credentials file, which contains the connection settings for the Proxmox server, because Packer needs to somehow authenticate to our Proxmox server and create virtual machines, execute tasks, and so on. The API URL contains the IP address of the Proxmox server, the web interface port, and the URL path that leads to the API module. And we also need to authenticate with an API token and a token secret. So if you don't know how to create that in Proxmox, you just need to go into the web interface, select your data center and go to Permissions, API Tokens. Add a new API token for a specific user. So in my case, I've just used the root user because this user already has all the privileges we need in Packer, but you can also create a separate user according to the Proxmox builder documentation with limited permissions, of course. And then you just need to enter a name for this token ID. And now it's really important to deselect the privilege separation setting, because we want our API token to have the same privileges as a root user. Note that the API token secret will only show up once, so when you close the window and forgot the secret, you just need to create another one. And then you need to enter these settings in the credentials file. So take care of the API token is the username and the token ID separated with an exclamation mark. Now that we have configured our credentials, we now can define our Packer template. And all my templates consist of 3 different sections. So first we will describe the variables used in the credentials file, and then we define our resources and the individual settings for them. And the last section is the build section, where we define which resources should be built and how they should be provisioned. So let's now have a look at the resources we want to create from the type Proxmox, which I have called Ubuntu Server Focal Test 1 in this example. So now it's also important that you set the correct parameters for the connection settings. They should match the variable names that you have declared above, of course. And if you have used any self-signed SSL certificate in your Proxmox web interface and you get a certificate warning, you also need to use the insecure skip TLS verify parameter and set this to true. And then we start defining the settings for our VM template. So if you want to have a complete list of all these different parameters, you can just look at the Packer documentation for the Proxmox builder. So there everything is documented, but I will walk you through the most important settings, of course, that I have used here in this template. So the general settings should be pretty straightforward, such as the Proxmox node, the unique VM identifier or the VM name, and you should also select an ISO image from which the VM template is installed. So in my example, I just used a local ISO from an Ubuntu server that I installed and downloaded on the Proxmox storage before, or you can also download it from a URL resources in the Packer template. And then you can also configure the other VM settings, like if it should have a guest agent installed, the storage controller, virtual hard disks, or how many CPU cores and memory it should have. And also the network configuration is really important, because the virtual machine needs to be able to connect to your workstation when you're running Packer. But I will explain this in a minute why this is so important. So just select a bridge interface where you have a DHCP server running, so the virtual machine gets an IP address and can connect to your network. And then you should also enable the Cloud-Init settings, so that will tell Packer to prepare the VM template with the Cloud-Init storage. Okay, so far so good. So now comes something that I think is absolutely cool, because you might wonder, so how does Packer install the operating system automatically from an ISO? Because during the installation procedure, the Ubuntu server asks us a few different things we need to enter in the console, like setting up a username or an IP configuration, choose the packages that needs to be installed, and so on. So that's why Packer has a list of boot commands that it can inject into the console window when the virtual machine is started. So for every button that needs to be pressed or text that you need to enter somewhere, you can define instructions in Packer to do it automatically. So now which buttons you need to press is, of course, different for every Linux distribution, because every system has a different installation procedure. And these boot commands I'm using in this template are working in Ubuntu 20.04 LTS, and they will press a few buttons in the menu and then finally run a command which is called auto install. So if you don't know auto install, this is a new function introduced in the latest version of the Ubuntu server, and it will perform an unintended installation. This is also sometimes called a preceded installation. So when you are at the boot menu to install Ubuntu, you can enter this auto install command that will perform this automatic installation by fetching the instructions from a web server. And that's why in the auto install command we also need to enter a data source, which is called now Cloud-Init, and the source definition is a URL with an IP address and a port. So we just need to run a web server on this IP address that can deliver the installation instructions for Ubuntu as a text file. And then during the installation, the Ubuntu server will open a connection to this web server to get and apply these instructions. So this is what Packer is also doing automatically in the background. So when Packer creates the virtual machine, it will also start a small web server on your workstation and wait for the Ubuntu server's connection. So that's why the network configuration is so important, because if the Ubuntu server can't connect to the web server that's running on your workstation, it can't fetch the installation instructions. When Packer runs the auto install command, it will replace the .http IP and HTTP port variables with your workstation IP address and a random port. You can also bind the web server to a specific IP address on your workstation and limit the random port numbers by setting these parameters. And in the HTTP directory, you can define the installation instructions that are served by the Packer's web server. So in this folder, you need to create two files: the metadata, which can be empty, and the user data, where you put the installation instructions for the Ubuntu server. So in this file, I have defined some basic settings like the language settings and the keyboard layout that the Ubuntu server should configure. And also some other settings can be customized during the installation procedure. So for example, this Ubuntu server should also install an SSH server and allow password authentication. This is important for the Packer scripts, which will perform provisioning tasks via SSH later. And here in the next section, you should also define which packages should be installed. For example, the sudo package and the QEMU guest agent. And in the user data section, you can also define the time zone and a user account which should be created. Again, this is important because Packer will use the user account later to connect to the VM for provisioning tasks. So enter a user that is allowed to execute sudo commands and enter a password or an SSH key you want to deploy on this server. So technically, you can also add more provisioning tasks in this auto installation script, but I'm not using this to install any software on this server. In this step, it's only important that Packer installs the Ubuntu server and creates a user account I want to use later. Because when we go back to our template, you can see that in the next steps, we define SSH credentials. And this should be the same as the one in the user data file, of course. You can choose whether you want to use a password or a private SSH key file. That is important for the following section. I know this is a lot of information, so trust me, I was completely overwhelmed by this as well when I saw it the first time. But I would just recommend doing a few tests with your own templates and starting with a simple task. So don't overcomplicate it, because then troubleshooting can get a little difficult if it's not working and you actually don't know at which point it's failing. So maybe just try to run this script and open a console window of the VM in Proxmox while Packer is running, and then you can see what it's doing and if it's entering the correct boot command and the correct instructions, and if everything works as expected. Okay, so that was the first part where we defined the VM template resources and how Packer delivers the auto install instructions to the Ubuntu server. Now in the build section, we define how this VM template is created and provisioned. So you need to enter the name of the resource that you want to build, and then you can add provisioning scripts that Packer will run on this VM via SSH, for example. So that's why it is so important to configure the SSH authentication. So here I added an inline shell script that Packer executes once the server is booted up. I won't go into too much detail here, but you can just easily summarize the first 3 steps as a post-installation, cleanup and preparation task for Cloud-Init. So remember when I said the image needs to be prepared to work with Proxmox Cloud-Init functionality? So this is exactly what this script is doing. So it will, after the installation of the Ubuntu server, clean the machine ID, which is important in Linux if you want to use it as a clone template, and then run a few cleanup tasks on the apt package manager. It will copy a file, which is important for the Proxmox Cloud-Init functionality. So all these 3 steps are important that you can clone this VM template and inject specific settings later with Cloud-Init, like giving this machine a different IP address or adding another user account and add another SSH key to it. And after these 3 steps, you can also do anything else, like installing Docker, for example. So this section here just executes all the necessary shell commands that I've just copied from the Docker installation guide for Ubuntu. So it will download the packages, it will add the apt key and install the Docker CLI and the daemon on this machine. And once this is done, so when Packer has created the machine, it has successfully run the provisioning scripts. So then it will finally convert this virtual machine to a template in Proxmox. So let's run this and let's hope for the best. Before starting the build process, I would always verify if the Packer template is valid. So with the command packer validate, you can check if you have any errors in your file. So always specify the variables file with the credentials, otherwise Packer doesn't find it. And then when everything is okay, you can execute the build task with the same parameters. And when you go into the Proxmox web interface, you should also see in the logs that it's doing something. Here you can also see it just created this virtual machine, and if you go into the console window, You can also see when the machine is booting that Packer presses the buttons you have defined in the boot command section and it enters the correct auto install command. So now the Ubuntu server boots up and it should start the unintended installation. So here in the Packer CLI you can also see if it starts the web server and waits for the Ubuntu server to connect. And once this is successful, it will just wait until the server is installed to run the SSH provisioning scripts. So this can take some minutes depending on how fast the installation process is on your Proxmox server. And once this is done, the server is booted up, Packer tries to connect to it via SSH and run the provisioning shell script. So here you can see it does the cleanup tasks and it's preparing the Cloud-Init files. And here my Docker installation shell script is also running. And if this is all working as expected, in the end you should have a new virtual Ubuntu server with Docker installed that has the Cloud-Init files prepared, and Packer will convert this to a VM template. And here it is. So that's our new VM template that Packer has created for us, and it's now ready to be used. So let's now see how fast we can deploy this virtual machine from it. So hopefully it will just take a few seconds or yeah, maybe 1 or 2 minutes as I promised you in the title of this video. Let's see. So first let's clone this to a new virtual machine, and then in the Cloud-Init section we can enter our username or add any additional public SSH key. I also want to give this VM a static IP address and gateway information to connect it to the internet. And then if you have entered all your settings in the Cloud-Init section, it's also very important that you don't forget to click on regenerate image to apply these settings into the image file. So now we can just run this virtual machine and wait until it's booted up and connect via SSH. And that's it, the server is now up and ready. So yeah, the linked clone works blazing fast. Not even a minute and the machine was ready. It has Docker automatically installed, everything else that we've defined in the shell script, so that's really cool. The full clone might take a bit longer because it first needs to copy the whole virtual disk, but I hope you agree with me that this is absolutely amazing and it can save you so much time when working a lot with virtual machines or Proxmox. I'm really excited about this. So that all might seem pretty easy and awesome, but to be honest guys, I've gone through hours of testing and troubleshooting before it actually worked on my PC, because there are so many things involved into all these different processes which can all go wrong. So I'd like to share some of the mistakes I did or things that I have observed you might need to customize or fix based on your environments. So first, if you start Packer and try to build the VM template, you might see some application crashes or errors. And even if this seems like a critical application issue, very likely Packer can't connect to your Proxmox server in the first place. So mostly your API token or the IP address in your credentials file isn't correct, or the API token might not have the correct permissions, so check if you have everything done like I've described in this video. And then if that somehow works, I still often had the case that the auto install procedure on Ubuntu didn't work. So the Ubuntu server booted, but it threw me back into a graphical user interface to proceed the installation manually, and then it never continued. And this is always the case if the auto install procedure can't connect to your Packer's web server or the files served by it aren't correctly formatted. So first look at any IP address conflicts or connection problems. So for example, if you're running Packer in WSL2, it's very likely that the Ubuntu server can connect to your WSL2 instance because Windows creates it on a separate network. It's just a mess to work with WSL2, so I just ended up running this in PowerShell, or if you're using Linux natively on your workstation, that should be also fine. And I also had the case that Packer always picked the wrong IP address from my Windows machine because I have so many network interfaces in my PC and it just picked the wrong one. In this case, I needed to statically define the IP address of my workstation into the auto install command or just bind the Packer's web server to this IP address. Also, if the user data file isn't formatted correctly, it will just go wrong and fall back to the manual installation as well. So for example, if you didn't indent some parameters in the correct order or you have any misconfiguration here, it also doesn't work. And troubleshooting all these problems isn't easy because the VM doesn't really say what it's actually doing in the log file, so it will just throw you back into the graphical console. It's a bit annoying, but yeah, you might need to go through some trial and error yourself, just like I needed. Now you might also ask, how can we take this a step further? Because we have still created this virtual machine manually. And yeah, there's also a way how you can automate this whole process with tools like Terraform, for example. So you can create your custom VM templates with Packer and then use Terraform to create virtual machines from it. Fully automatic. I've already done some tests with the creation of multiple VMs for my Kubernetes cluster on the server, so that might be also a small hint what's the topic of one of the next videos. So don't worry, there will be more stuff about these things, and I believe this is absolutely amazing because you can use automation tools that cloud providers and enterprise companies are using and practice with them in your own home lab. This is something I absolutely love about IT, and if you're interested in more videos like this and you feel like these videos are helping you, you're welcome to return the favor by liking the video and subscribing to the channel. That would be really great. And as always, thanks everybody for watching. Take care of yourself and I'll catch you in the next video. Bye bye.